class, and welcome to the last video of the year. Oh, I know it's depressing. Grab the Kleenex box and cry a little tear for me. Okay, no, I'm just kidding. I hope you're probably happy that we're almost done our last video lesson. Thanks for hanging with me all semester. It's been a pleasure, and best of luck on your exams and best of luck in your future. Thanks. I'd also welcome any feedback, ladies and gentlemen, you want to give me on my videos. That would be great. All right, so ladies and gentlemen, we have to remember for our last one that it's Unit 7 and 8. Unit 7 dealt with congruent and similar triangles that we're going to take a look at here. And then we spent most of the time on trigonometry, which is dealing with solving angles and side lengths in triangles that were both right angle triangle and oblique triangles. First thing we want to do is let's discuss about congruent triangles and similar triangles. Congruent triangles have equal angles and equal sides. Okay, so when you take a look at some tiling or patterning and the tiles keep repeating and they're the same size, that's what's called congruent triangles. So they have equal angles and equal sides. Similar triangles, the symbol we use for congruent is an equal sign with a tilde on top. Okay, similar triangles, folks, they also have equal angles. But how they differ is by the side lengths. But they have what are called proportional ratio sides. Okay, so maybe one triangle is 3 times the size of the second triangle, or a third of the size. I always think about this if you have scales, like on a map, right? Okay, think about scales. And the short form for similar triangles is just a similar tilde. Just a tilde for similar triangles. Okay, so that's a symbol used for similar triangles, and for congruent, it's the equal with the tilde on top. All right. Ladies and gentlemen, here is a copy of what you wrote down, probably lesson, I think, 8.0. And here's the strategy we use for when solving triangles with trig. Okay? When solving triangles, we have to discuss the different methods used based on the type of triangle. So if it's a right triangle, you're either using Pythagorean theorem, which is c squared equals a squared plus b squared, or if it's a right triangle, using SOHCAHTOA. Use SOHCAHTOA when you either are finding an angle or when angle is given. Awesome. The other option, folks, is if you have an oblique triangle. An oblique triangle, remember, has no 90-degree angle, so you're going to use a sine law if it has a match, or you're going to use cosine law if it's the last two cases, which is side angle side or side 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 given. All right. Let's take a look at proving some similarities here. It says, given that two triangles are similar, solve for x. Well, first of all, we've got to take a look at the arrangement of how triangles work when they're connected in this pattern. Hopefully you remember the geometry that this angle will equal this angle. Likewise, this angle will equal that angle. And by process of elimination, if two angles are equal, then guess what? The third angles are equal. So we have to make sure when we set up one triangle, compare it to the other, that we make sure we set it up correctly. So if I'm trying to find x, folks, x is in the smaller triangle over the corresponding side in the bigger triangle, which is going to be 13, equals where we have the match, which is two values given. So it's going to be 4 over 12. Now, I don't want to say match, like it's not like what we used in sine law, but it's the one that has the values in both the numerator and denominator. Okay. Now we're going to cross multiply, folks. So x times 10 is 10x equals your opposite cross. Plug that in your calculator or use your brain, and you're going to find that that's 52. And to get x by itself, divide both sides by 2. So x equals 5.2. And what are our units here, folks? Centimeters. Awesome. Okay, take a look at number 2. Now we're moving on with angles. So when we move on with angles, that means we're doing trigonometry. Okay, so for angle, or for A, it says find angle R. So looking at angle R, folks, do we have a right triangle? No, none's given. So we can't use SOHCAHTOA, we can't use Pythagorean theorem. Do we have a match as given in triangle PQR? Nope. Can we find one? No. Why can't we? Because no angle is given. Okay? So if we can't use, we don't have a match, we can't use sine law. So by process of elimination, we have to use cosine law. Okay? So to do cosine law, ladies and gentlemen, you take the cos of the angle you're finding, which in this case is R. Okay? And that equals the two sides that are beside it squared, so 2.2 squared plus 2.5 squared, but you always have to subtract the opposite side squared. Now this formula you'll find on your formula sheet, folks. You don't need to memorize it. You just need to know how the pattern works. Divided by 2 times the two sides that touch R, which are 2.2 and 2.5. Okay? Get your equation, ladies and gentlemen, and you're going to have cos R equals, the numerator works out to 8.2 divided by the denominator, which is 11. Remember, folks, when you're finding an angle, you got to do the cos inverse, okay, of this fraction. So 8.2 over 11. Plug it in your calculator, ladies and gentlemen, and you're going to get R equals approximately 42 degrees. Okay? Oh, okay. Everybody good with that? All right, next one, K for B part, angle K. So I'm looking at angle K, ladies and gentlemen. First of all, strategy. Do we have a 90-degree triangle? No, we don't. So we can't use SOHCAHTOA. So what we're going to do is we're going to look for a match. Do we have a match? Yes, we do, because we've got the angle and the opposite side given. Okay? And the good news is the angle we're trying to find has its opposite side length. So this tells us we're to use sine law because we've got a match. Okay? All right. So what we're trying to find is angle K. So we go sine of K, and yes, that spells sync. Okay? Divided by the side of K, which is 13, equals the sine of the match, which is 60 degrees, divided by the side length. Okay? Remember, you can flip your fraction for sine law. Although it might say A over sine A equals B over sine B, you can flip it, okay, and to put the angles on top. Okay? So what I'm going to do is find sine K equals the opposite cross. Remember how to do this, folks? Opposite cross, so 13 sine 60 degrees, and divide it by what you would normally multiply by, which is 17. Now we need to get the angle by itself, so angle K equals the sine inverse of this entire fraction. Okay. Plug it in your calculator, ladies and gentlemen, and you'll get angle K equals 41 degrees. Okay. Next one, length of K. So remember, it's a lowercase, so that's a side. So length of K is always opposite the angle K. Okay, look at this triangle, folks. Do we have a right triangle? Yes, we do, because there's a 90. Okay, do we have an angle? Yes, that tells us we're using SOHCAHTOA. Okay. The angle given is 38 degrees, so from that, what side has the information in it? So for example, 32 millimeters is what we call the opposite side, and K that we're trying to find is the hypotenuse. What ratio has an O and an H in it in SOHCAHTOA? It's going to be the first one, so it's going to be sine ratio. So sine of the angle, 38 degrees, equals, it goes in order, opposite, which is 32, divided by K. K is on the bottom, and remember to switch it, or to solve for K, you do the switch. So K equals 32 divided by sine 38 degrees. Plug it in your calculator, ladies and gentlemen, and K equals approximately 5.2, and our units are millimeters. All right. Last question, ladies and gentlemen. From the ground, you see the top of a flagpole. You see the top of a flagpole is at an angle of elevation of 67 degrees. So, got a flag here. There's my lovely flag here, Canada. Here we go. Woohoo! Should be red, actually. Here, let me change that. All right, I can't waste any more time. There we go. Pretend that's a Canada flag. Okay, it says from the ground, the angle of elevation to the top. So from the horizon up, ladies and gentlemen, that's 67 degrees. If you are standing 10 meters from the pole, so that means that this measurement right here is 10 meters. It says how tall is a flagpole. So we're going to let that be X, and hopefully the flagpole is installed properly and it's 90 degrees from the ground. We just make that assumption. Since we've drawn a diagram and we have an X, we've got to put a let statement in. So let X represent height of flagpole. Okay. So from the given angle, folks, what two sides do we have? We know this is a right triangle, so we're using SOHCAHTOA. We have the opposite side, and we have the adjacent side. In SOHCAHTOA, which one has an O and an A in it? I'll scoot back up. Which one has an O and an A in it? This time you're going to see it's what? Tan. I'll put down here number 3 to not confuse people. Okay? And I'll put that number 2. Okay? All right, so if we know we've got tan, we're going to go tan of 67 degrees equals the opposite side, which is X, over the adjacent side, which is 10. X is on top, so you simply cross multiply, ladies and gentlemen. Plug it in your calculator, and you're going to get 23.6. Because it's a word problem, we're going to say, therefore, the flagpole is 23.6 meters high. Awesome, ladies and gentlemen. We are done. Okay, now you've got to work really hard at getting your study sheet ready, or sorry, your extra practice booklet finished. Get ready to do your practice exam and come and see me if you need extra help. Good luck on all your exams, folks, and great success in the future. I wish you well. I wish you peace and love. Goodbye. Bye.